slope of velocity time graph. Slope of velocity time graph. Velocity time graph. We have to know what does the slope of velocity time graph indicate. We can draw velocity time graph of an object which is moving with non-uniform velocity. Here this is the velocity time graph. Velocity time graph, horizontal axis is time axis and vertical axis is velocity axis. Vertical axis is velocity axis. Horizontal axis is time axis. This is a velocity time graph. A be a point on this velocity time graph. We can draw a normal on the time axis. The normal is A in at the point in, and also you can draw a normal on velocity axis from the same point, and at the point in the value of time is t second, and at the point B the value of time, this normal is Bm. A normal Bm is drawn from the point B on the velocity time graph. At the point M the time is t plus delta t, and at the point A the velocity is v, and we can draw a normal from the point B on velocity time graph on the velocity axis, and at the point B velocity increases to v plus delta v. We can draw a line parallel to time axis, that is AC, from the point A. At A we can draw a tangent AT, we can draw a tangent AT, and that tangent AT makes an angle theta with the time axis. Let v be the velocity v be the instantaneous velocity of an object. Instantaneous velocity of an object at the point A at an instant t, at an instant t, and if it travels from A to B its velocity increases from v to v plus delta v plus delta v, where delta v is small increase in volume, increases from v to v plus delta v in the small interval of time delta t, small interval of time delta t. Now theta be the angle subtended by the tangent at at the point A on the velocity time graph. Theta be the angle subtended by the tangent at at the point A on the VT graph or velocity time graph. Velocity time graph. OD, O prime D. The velocity time graph is O prime D. This point is D and this is O prime, the initial point of velocity time graph, and O is the origin. Theta be the angle subtended by the tangent AT at the point A on the velocity time graph O prime D. Now AT is the tangent, which is denoted by blue color, and for my students, no need to denote this blue color notation, so it is denoted to explain. Here this is the angle theta subtended by the tangent AT with the time axis, and it is the tangent. It is the tangent. And theta is the angle subtended by the tangent AT with AC, means with the time axis, because AC is parallel to the time axis. Theta be the angle subtended by the tangent AT at the point A on the velocity time graph O prime D. Therefore, the slope of the graph O prime D is given by tan theta equal in the right angle triangle ACB. Tan theta means perpendicular, which is BC, by base means AC. Tan theta equal to BC by AC. Now we can denote the value of BC and AC on the graph. Here the value of BC is small change in velocity, that is delta V. This is the value of BC equal to delta V, and delta T is the value of AC, interval of time between the 2 points A and B. That is, the length of AC is delta T, small change in time. Now tan theta is equal to tan theta will be equal to, now you can put the expression of BC here, limit delta T tends to 0, which indicates that interval of time is very small, and BC is delta V and AC is delta T. Limit delta T tends to 0, delta V by delta T, which is tan theta. Therefore, tan theta is equal to limit delta T tends to 0, delta V by delta T, where BC is equal to delta V and AC is equal to delta T. And as the interval of time, that is delta T, is very small, that's why we have written limit delta T tends to 0, which is equation 1. Tan theta is equal to limit delta T tends to 0, delta V by delta T. Also, the instantaneous acceleration, the instantaneous acceleration the instantaneous acceleration of the object or of the body at an instant t is given by ai equal limit delta t tends to 0, delta v by delta t, delta v by delta t. That is the expression of instantaneous acceleration, limiting value of average velocity in small interval of time. ai equal limit delta t tends to 0, delta v by delta t, which is equation 2. So if we compare equations 1 and 2, then we can say that the slope of, therefore, the slope of VT graph, the slope of VT graph is given by, is denoted by small m. Small m is tangent of theta, tangent tan theta, where theta is the angle subtended by the tangent AT at the point A with the time axis. And in place of tan theta from equation 1, we can write limit delta t tends to 0, delta v by delta t. Therefore, m equal ai. Here it should be limit delta t tends to 0, not only delta t. So, m equal ai. M equal ai, which is what? Slope of velocity time graph, VT graph, slope of velocity time graph. Therefore, the slope of velocity time graph of an object or of a body is equal to its instantaneous acceleration. Not only acceleration, it should be instantaneous acceleration of the object at that given instant.